Good morning. In this class, I am going to explain arrays and types of arrays. Arrays and types of arrays. Up to the previous videos, we have seen we have seen 1, 2, 3 chapters, and now this video onwards we are entering into the fourth chapter, that is arrays and types of arrays. Arrays and types of arrays. In the first chapter, that is, I want to give a brief about 1, 2, 3 chapters what I have discussed in the previous videos, and after that I will enter into the fourth chapter and what we learn in the fourth chapter. What we learn in the fourth chapter. In the first chapter, that is the problem solving methodology and introduction to C language. Problem solving methodology and introduction to C language. In the second chapter, data types, constants, types of operators, and in the third chapter, decision making and looping statements. And now we are entering into the fourth chapter, arrays and strings. So here this is connected with the second chapter, data types. The second chapter, that is data types. In the data types, there are three types of data types are there: basic data types, derived data types, and user defined data types. Basic data types, derived data types, and user defined data types. The basic data types are integer, character, and float. The basic data types are integer, character, and float. And the derived data types are the derived data types are arrays. One of the derived data types is arrays. In this is comes under fourth chapter. This is comes under fourth chapter. In this chapter, we are going to see in this unit arrays and strings. The chapter name is arrays and strings. In this one, we are going to see what do you mean by an array? What do you mean by an array? And how to declare, how to create an array, and what are the different types of arrays. What are the different types of arrays? And integer array, character array, the character array is nothing but strings. The character array is nothing but strings. A string is a collection of characters. A character data type variable, a character data type variable stores only a single character. A character data type variable stores a single character. If you want to store a string, that is a collection of characters, that is our names like Raju, Ravi. For that purpose, we need to use character arrays. Character arrays. And to store string a string into that arrays, there are some special functions: get string and put string. We have seen get char and put char functions to read characters. We have seen get char and put char functions to read characters, and the same way to read strings. There is a get string and put string function. There is a get string and put string function. And some string functions are there. Predefined string functions are there. That is string length, string reverse, string comparison, string length, string reverse, string comparison, like that. Some of the built-in functions are available in string.h header file. So I'm going to start. This is Arrays and types of array. What do you mean by an array? Arrays, or what do you mean by an array? An array is defined as the collection of similar type of data items stored in continuous memory locations. Arrays are the derived data types in C programming language which can store the primitive types of data such as int, char, double, float, etc. Here in general, here in general, if you declare a integer variable, for example int a comma, like this, I want to show you the paint. For example, if you have written a program that is main, in that one int a comma b comma sum, if you have declared a variable like this int a comma b comma sum, the variables are created in the memory. So this is, assume this is a memory. So in this, the variables are created like this. In this, the variables are created somewhere else a, and somewhere else b, and somewhere else sum. Here somewhere else a, that is a, variable a, and here somewhere else b, and here somewhere else sum. If you think this is a physical memory RAM, the physical in the physical memory RAM, the variables are created like this. If you assume this is a RAM, if you assume this is a memory, this is a memory, this is the memory. So here the variables are created, a is somewhere else, b is somewhere else, sum is somewhere else. So the address of the variable, that is a, is a different address, and b is a different address, and sum is a different address. We already know for each and every variable there is a unique address. We already know for each and every variable there is a unique address. Okay, so by using that address only, the compiler places the value, insert a value into that memory location, and reads a value from that memory location. For the convenience of the programmer, we are giving it as a name of a variable. For the convenience of programmer, we are giving it as a name of a variable. So here, when you create a variable integer a comma b comma sum, or float variable, or character variable, so the variables are created in the memory in a position that is a random order. The variables are created in the memory in a random position, random order. It is not in a continuous order. So the memory is very big, the size of the memory is very big. So the variables are created, it depending upon the operating system or the compiler, randomly created. So here in one program I am using only three variables, that is the program is addition of two numbers. Here I am using only three variables, that is a, b, sum, for storing a value a and storing second value another value b, and for storing the result, that is sum is equals to a plus b. So no problem, only three memory locations. But if another program you take, if you want to add, you want to store 10 subjects marks. I have 5 theory subjects and 5 practical subjects. I have 5 theory subjects and 5 practical subjects. So I have to store 5 plus 5 10 subjects, and then afterward I have to calculate sum of that 10 subjects and average of that 10 subjects, like that, sum and average, like that. So here we need to declare 10 variables, 10 variables. So in order to write a program, that is int s1 comma s2 comma s3 comma s4 comma s5 comma s6 comma s7 comma s8 comma s9 comma s10 comma total. So in this program, that is in our diploma, we have 5 practical subjects, 5 theory subjects and 5 practical subjects in every semester. So I have to calculate the sum of this 10 subjects. I have to store 10 subjects marks, and I have to calculate the total, that is sum of 10 subjects. So in this way, when you are creating more number of variables, when you are creating more number of variables in the program, that is of type same. Here one more thing, one more point we need to understand is creating more number of variables of same data type. Creating more number of variables of same data type, of same data type. So here creating more number of variables of same data type. So that is integer s1, integer s2, integer s3, integer s4, integer s5, integer s6, integer s7, integer s8, integer s9, integer s10. So here all these variables from s1 to s10 and total, which is to be sum1 plus sum2 plus sum3 plus up to s10, that is subject to 10. So these many variables are created in the memory in a random order. These variables are created in the memory in a random order. So sum1 is created at some location. Sorry, s1 is created at some location, that is subject 1, and s2 subject 2 is created at somewhere else, and s3 subject 3 is created at some other location. So here the problem is all the variables are created, so but inserting a value, inserting a value into that memory location, inserting a value into that memory location is a difficult process. Inserting a value into that memory location is a difficult process. Means it is a time taking process. It is not a difficult process, it is a time consuming process by the compiler. So because all these variables are created in the memory in a random places, in a random places. So here searching each and every location to insert a value and to retrieve a value, it's a time taking process to the processor, time taking process to the processor. So here 10 variables, okay, but if any program needs to create some 30-40 locations of same types, if any program needs to create a 30 or 40 memory locations of same data type, if any program needs to create the memory locations that is of 30 to 40 of same data type, it is a problematic, it is a problematic means it is a time taking process to search that location, to insert the value and to retrieve the value. So instead of creating individual variables of same data type, we can create arrays, we can create an array, we can create an array. So here the advantage of arrays is when you declare an array variable, the memory locations are created in the memory in a continuous order, in a sequential order, in a continuous order, in a sequential order. So here the advantage of arrays over this creating individual variables of same data type, individual variables of same data type, of same data type, the individual variables are created in the memory in a random order, in a random order, but the array variable created in the memory in a sequential order, in a sequential order. Here 10 variables are different names, 10 variables are referred with different names. That is S1, S2, S3, A1, A2, A3. These are all the different names. Here in the array variables, if you create 5 locations, 10 locations or 50 locations of same type as an array variable, these locations are referred with only a common name. These locations are referred with only a common name. These locations are referred with only a common name. Only a common name. So here the arrays comes under derived data types. These are created for the basic data type int, char, float. The advantages of arrays is when you create the variables of same type in a program, that is integer a1, a2, a3, a4 like that, 2-3 variables no problem. If you are creating more than 10 variables of same type, then it is a confusion to the programmer also. And technically these variables are created in a random location So it is a very big time taking process to the compiler to identify its address, to insert and retrieve values from that locations, to insert and retrieve the values from that locations. So to overcome this problem, the arrays were introduced. The arrays were introduced. It is very simple to create. The arrays are very simple to create. For this program, int s1, s2, s3. So here how many locations are there? 10 locations for storing 10 subjects. Here we can create an array like this. Main int s of or else subjects of 10 comma dot int sub of 10 comma dot. Like this we can create. So before that we have to see the definition of array and observe how the array is created in the memory, and then how to store the values in the arrays, how to store the values in the arrays, and what are the different types of arrays: one dimensional, two dimensional, multi-dimensional, like that. And we will see some programs. We will see some programs also. Here the definition of array. An array is defined as the collection of similar type of data items stored in continuous memory locations. An array is defined as the collection of similar type of data items stored in continuous memory allocations. Arrays are the derived data type in C programming language. Arrays are the derived data type in C programming language, which can store the primitive basic data types such as int, char, double, float, etc. Which can store the basic data types. Primitive data types means the arrays are called as the derived data types, because these are created which can store for the purpose which can store the primitive types of data such as int, char, double, float, etc. Which can store the primitive types of data such as int, char, float, double, etc. There are many applications which require to process a group of data items that are same type, such as int, float, char, or double. Here there are some of the applications or many applications which require to process a group of data, which requires to process a group of data items that are same type, such as int, float, char, or double. Here the array definition is the array Definition is the definition of the array is a collection of memory locations referred with a common name. Array is a collection of memory locations referred with a common name. Referred with a common name of similar data type of items. It's a collection of similar data elements referred with a common name. It is a collection of similar data type elements referred with a common name, and it stores in a continuous memory locations, in a continuous memory location. In general, if you created a variable integer a, integer b, this is created somewhere else in the memory. Here a is created here, b is created here, and sum is created here. Created here, b is created here, sum is created. And this is the type int, and this the type is also int, and this the type is also int. Type int, int. This is the type int, and the type int, and this variable also type int. But these are created randomly in a random different memory location. These are created in a different memory locations, not in a sequential order, not in a sequential order. So here, if you are creating more number of variables of same data type, it is a time taking process to the compiler to insert and to retrieve the values. First of all, it requires time, it takes more time to identify that location, to identify that location. So going into that location and inserting a value, and the same going into that location and retrieving the value is a time taking process. Okay, so one or two variables, it's no problem. If you are creating more number of variables, so some of the applications requires more number of variables of same types. Some of the applications requires more number of variables of same data type. In that situation, it is a time taking process to the compiler. So going and searching in that locations and inserting and retrieving the values from there. So it is also a confusion process. It is a confusion task to the programmer. If you are creating 20 variables of same type, if the programmer confusionally omit one location, one variable name, then the program is total program gives an error output, gives an error. It does not give an accurate result. So here the it is also confusion task to a programmer. So for that purpose, to avoid all these things, to avoid all these things, so arrays were introduced. An array is defined as the collection of similar type of data items. An array is defined as the collection of similar type of data items stored in continuous memory locations. Stored in continuous memory locations. Arrays are the derived data types in C programming language. Arrays are the derived data types in C programming language, which can store the primitive, which can store the basic data types, which can store the basic data types such as int, char, double, float, etc. Such as int, char, double, float, etc. There are many applications which require to process a group of data items that are of same type, such as int, float, char, or double. Here there are many applications which require to process a group of data items that are of same data type. Same type means same data type variables, data type variables such as int, float, char, double. So for example, we can define any array, we can define an array to store list of marks obtained in different subjects in an examination by student. For example, we can define an array to store list of marks obtained in different subjects in an examination by a student. So here's this example. Integer subject 1, that is S1, subject 2, subject 3, subject 4, subject 5, like that. We have 10 subjects in diploma in every semester, 5 theory subjects and 5 lab subjects. So in this application, so the arrays are very useful. The arrays are very useful to create memory location and to store the values, to create a memory location and to store the values. See here, see this diagram. Array size is equals to 5, and these are the 5 locations. This is nothing but memory location. This is nothing but memory location. See here, this is nothing but memory location. First box, it means that here it is an array. These are all 5 different locations of same type integer: location 1, location 2, location 3, location 4, location 5. Location 1, location 2, location 3, location 4 and location 5. Location means memory location. Location means it is a memory location. It is a memory location. Location means it is a memory location. Five memory locations are there. 0, 1, 2, 3, 4. These are called index numbers. The first location number is 0, and the second location number is 1, and the third location number is 2, and the fourth location number is 3, and the fifth location number is 4. These are called as index numbers. These are called as index numbers. The first location number referred with 0, the second location number referred with 1, and third location number referred with 2, and fourth location number is referred with 3, and fifth location number is referred with 4. Like this, the array is created in the memory. Like this, the array is created in the memory. 0, 1, 2, 3, 4. In the next video, I will explain very clear about the creation of arrays. In the next video, I will explain very clear about the creation of an array and how it is created in the memory. How it is created in the memory, I will explain it very clearly. In this class, I have explained to you what are the basic data types are there, and if you are creating more number of variables of basic data type, it is a time taking process to the compiler to insert and retrieve the values, and it is a big task of the programmer, confusion task. Then to overcome this, the arrays were introduced. Okay, thank you.